Hello, everybody. This is Pre-Algebra Chapter 4, Lesson 8. We are today working on solving with division. So in the last video, we were solving problems that had multiplication, right? So for example, if I had a division problem that said, I don't know, some number m divided by 5 is equal to 10, I had to figure out what m was worth. And how did I do that? Well, I tried to get m by itself on one side of the equation, of the equal sign, excuse me. And so how did I do that? Well, I simply tried to get rid of the divided by 5. And so I used the inverse of division, which was multiplication. And so I did, instead of dividing by 5, I multiplied by 5. When I did to one side, I must also do to the other side to keep balance. And so I said, okay, nothing happened to the m. So I write that down there. Divided by 5 and multiplied by 5 cancel each other out because they're inverses. And then I drop the equal sign. And then I say, what is 10 times 5? And 10 times 5 is 50. So now I have my m, my variable, isolated by itself. And what I did next was I rewrote the original equation to prove it. I replaced my variable with what I said the variable is worth, and the variable is worth 50. So m is actually worth 50. Rewrite everything else. 50 divided by 5, is that 10? Let's check. 50 divided by 5. How many times does 5 go into 5? One time. 1 times 5 is 5. I subtract. 5 minus 5 is 0. I drop down the next 0. 5 goes into 0 no times, so that's a 0. 0 times 5 is 0. 10. 10 is equal to 10. It works out on both edges, on both ends of the equation. It is balanced, therefore, my m is worth 50 whatever points, okay? So that was solving with division, or solving with multiplication, sorry. That's because we used multiplication to solve a division problem. Now we are going to use division to solve a multiplication problem. Example, 6 times some number, again, let's call the number x, is equal to 18. Now, if you're thinking about picturing this, if I said if I had 6 boxes, and in each box there's a number, a certain number of rabbits. How many rabbits need to be in each box to get 18? Well, you could draw a picture of this, right? You could say, look, here are the 6 black boxes. 1, 2, 3, 4, 5, 6. The question is asking, one second. The question is asking, how many things need to be in each box to reach 18, right? So we find out. We go 1, 2, 3, 4, 5, 6. Have we reached 18 yet? No. Keep going. 7, 8, 9, 10, 11, 12. So far, there are 2 items, or 2 rabbits rather, in each box. Have we reached 18? Nope, we're still at 12. 13, 14, 15, 16, 17, 18. We have reached 18. So 6 multiplied by how many equals 18? Well, it's 6 multiplied by 3 in each, right? There are 3 rabbits here, 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 here. So we can say that 6 times 3, or 6 3 times, or 3, in this case, 6 times, is equal to 18. Now, how can we do that using algebra? Well, it's simple. It's quite literally the same thing. We do 6 multiplied, or 6x equals 18. 6 multiplied by x equals 18. And since I know that this is multiplication, what I can do is the opposite of multiplication. And what's the opposite of multiplication? It is division. And here's how we can represent division in 2 ways. Here's way number 1. Way number 1 is I can do this. I can say 6x equals 18, and then I can use the dot for multiplication, right? And then I could say, all right, I'm going to use the division symbol like this to get rid of the 6, right? So I could do, sorry, 1 second. I'm trying to get this right. There we go. 6 multiplied by x, and then I divide by 6. What I do to one side, I must also do to the other. So I divide 6 on both sides. The 6 and the 6, 6 divided by 6 is 1, right? 6 divided by 6, like terms, is 1. So I'd get 1 times x is equal to 18 divided by 6 is 3. 1 times anything is that thing, so 1 times x is x. X would be 3. One more time, I did like terms, 6 divided by 6. That gave me the 1. 1 multiplied by this x. 1 times x is x, because 1 times anything is itself. And then 18 divided by 6 on this side is 3. So that's one way to do it, but that way is a little confusing, I think. The other way you could do it is writing it like this. 6 multiplied by x is equal to 18. You could divide, when you put a line underneath everything like that, that's division. It's like a fraction, right? The numerator on the top. So you say 6x divided by 6. Because we're trying to get x by itself, right? What I do to one side, I must also do to the other. So I divide 18 by 6, just like that. 6 divided by 6 is 1, so they cancel each other out. So that's just left with x by itself. You don't need to write the line again, because technically it's x over 1, or x divided by 1, but anything divided by 1 is just itself. So we skip that step, and we go straight to x equals 18 divided by 6 is 3. X equals 3. X over 1 is the same thing as saying x divided by 1, but anything divided by 1 is just itself. So in this case, x divided by 1 is x. So now we test it. X equals 3, and we tested it over here already, and we know that 6 times 3 is in fact 18. Therefore, you know your answer is x is equal to 3. Okay? Let's try another problem. Now I'm going to do this problem in the simplest possible way so that you can get a more clear idea of how this goes. Let's say we have 35 is equal to 7 times y, or 7y. How do I solve this? Very simply. I look and I see that something times 7 is 35. Well, the simplest way to do that is to get rid of the 7. How do I do that? I divide by 7. Because I know it's multiplication, the inverse is division. And instead of using the division symbol, I'm going to use this line, which is underneath the 7y, because that also represents division. So I'm going to divide by 7 to both sides. 7 divided by 7 is 1, so it cancels out. So that leaves me with y on this side, and 35 divided by 7 on this side, and 35 divided by 7 is 5. So 5 is supposed to be y, or y is supposed to be 5. Let's prove it. First, I rewrite the original equation. Then I use substitution. And I replace, oh, I'm sorry. Yes, I replace the y with 5. So here's the y I'm replacing with 5. 7 times, I'm going to put the y in the 5 in parentheses. And then I have over here 35. Oh, I'm sorry, I rewrote this incorrectly. I'm sorry, I apologize. It's not 35 divided by 7 because that's when we were doing the work. It's 35. There we go. So let me start again. 35 is equal to 7 times y. I replaced the variable y with what we said it is, which is 5. So now I have 7 times 5. Does that equal 35? There we go. That makes more sense. 7 times 5 is, in fact, 35. Does 35 equal 35 on both sides? Yes, it does. Therefore, we know for a fact now that y is equal to 5 in this case. And that's how you use division to solve multiplication problems. Let's try it again. Let's go with, if I had x times 9 in parentheses equals 36. All I simply need to do is get rid of this 9 and put it on the other side. How am I going to do that? I'm going to use division. I'm going to divide by 9, the inverse. 9 divided by 9 is 1. What I do to one side of the equation, I must do to the other to keep balance. So now this becomes, in reality, it's x times, this 1 became a 1, right? Over 1. How did it become a 1 over 1? 9 divided by 9 is 1. So really it's not 1 over 1. What it really is x times 1 equals, and then 36 divided by 9 is 4. X times 1, anything times times 1 is itself, so x just remains x. And so x equals 4. If we were doing it the fast way, it would look like this. X times 9 equals 36. We would have divided by 9 on both sides. We would have canceled out. We would have rewritten the problem x equals 36 divided by 9, which is in fact 4. And we would have done it in 2 steps instead of 3. But I'm just showing you what goes on in between, behind the scenes. So since I say that x is equal to 4, now I can prove it. So I can do x, rewrite the original equation, times 9 is equal to 36. Then I could say, all right, let's replace this x with what we say it is, which is 4. 4 parentheses 9, which is the same as saying 4 times 9. 4 times 9, does that equal 36? Yes, it does. 36 does equal 36. It works. X is equal to 4. And that's basically it. It's actually a pretty simple system. If you see multiplication, you do division. If you see division, you do the inverse, which is multiplication. Let's do one more just for fun. Ooh, here's a good one. Actually, we'll do 2 more. So here's 9n equals 72. Let's make it color-coded so it can be consistent. 9 times n is equal to 72. What am I going to do? Well, I'm trying to get the n by itself, so I'm going to divide by 9 on both sides, the inverse of multiplication. 9 and 9 are going to cancel. They're going to turn to 1. 1 times n is n. 72 divided by 9 is 8. Now I prove it, so I go, so I do 9 times n is equal to 72. I replace the n with 8. 9 times 8. Does that equal 72? 9 times 8 is in fact 72. 72 on both sides of the equation. We are good. N does equal 8. Now, let's try one with 0 in it, and that will be our last one for today. If I tell you that 0 is equal to 2 times some number x, what is x? Well, I need to get x by itself, right? So I'm going to divide by 2 on both sides. 0 divided by 2, nothing divided by 2 is just nothing, so that's 0. 2 divided by 2 is 1. 1 times x is x. X is equal to 0. Let's test it out. 0 equals 2 times x we said was, oh, sorry, let's rewrite the equation. Then let's substitute in. So we've got 2 here, and then we've got this x, which is 0, we said, right? So 0 equals, what is 2 times 0? It's anything times 0 is 0. We've got 0 on both sides, therefore it works. 0 is equal to x. All right, ladies and gentlemen, that is the end of today's video. If you have any questions, please let me know. Besides that, we will see you in the next video.